Hello viewers, and welcome back to for final maths class. Continuing with the calculus, we are moving on to differentiation of implicit function. And then an implicit function is a function of x and y which neither variables, which is x and y, cannot be easily expressed in terms of one another or in terms of one. All right, so we have implicit function which has the variables x and y in the same expression, but when you look at the function very well, you cannot express x in terms of y, neither can you express y in terms of x. So if you have a function which is, say, x squared plus y squared to be equal to 5xy, when you look at this expression very well, expressing one of the variables in terms of the other would be very, very difficult. So therefore, we use the implicit function approach to simplify this particular thing or to find the derivative of this particular function. So this function that I've written on the board is an implicit function since we cannot isolate one of the variables on one side of the equation. All right, so maybe we cannot isolate y on one side of the equation, which we cannot do it very easily, or we cannot isolate x on one side of the equation very easily. So now to differentiate an implicit function, we have certain approaches that we follow in order to be able to differentiate a function of this nature. So one of the expression, or one of the first approach that we use is to differentiate it term by term to give us a function in dy dx, in x, and then in y. Okay, so the first thing is we have to differentiate that particular function in dy dx, x, and then what, y. So if you have the function to be in this way or the expression to be in this way, we will differentiate them term by term. So you have how many terms in this? 1, 2, 3 terms here. Okay, so we will differentiate them one term by one term, then by one term. Okay, and then after differentiating them term by term, this is what you will be obtaining the function in dy dx, in x, and then in y. That is the first thing. Now the second approach is that you will make dy dx the subjects. So after expressing them term by term, you make dy dx the subject. Okay, so you make dy dx the subject. Okay, now the third thing that we have to look at is that it is useful for us to know that if you have y, to differentiate y, okay, if you have a function which is just y, you will be obtaining dy dx. Okay, so if you have an expression where you have y which stands alone, you will be obtaining what? Dy dx. The next thing is if you are differentiating y squared. It is useful to know that if you are differentiating y squared, you will be obtaining y dy dx. Okay, the same way if you are differentiating y to the power 3, y cubed, you will be obtaining what? 3y squared dy dx, and so on and so forth. So you will have to, bear it in your head or bear it in mind that when you have y which stands alone and you are differentiating, you will be obtaining dy dx. If you have y squared, you will be obtaining y dy dx. If you have 3y, you will be obtaining what? 3y squared dy dx. And if it is what? Y to the power 4, you will be obtaining 4y to the power 3 dy dx, and so on and so forth. And then one of the most important things that you have to also notice when you are differentiating an implicit function is that if you have a function which is in the form xy or 3xy, all right, so you have to treat this function as a product. All right, you have to treat it as a product. So you use the product rule to resolve a function which is in the form xy or 3xy, or if x and y both variables meet and they are multiplying, you have to treat them as a product. Therefore you use what? The product rule. And then if you are new to this page, or if this is the first time that you are hearing the word product, you can visit my previous videos. We did look at what? Product rule, how to resolve a product of two functions. Okay, so you can visit that one. And also if you have a function which is in y over x, or you have something like 2x squared over y squared, that one too, you treat it as what? Quotient. you treat that one too as quotient. So you use the quotient rule to treat such an expression. So if you have it in this way, you treat it as what? Quotient. And you have it in this way, you treat them as what? The product way. Okay, so you use the product and the quotient rule to treat expressions of this nature. Okay, so now if you have the formula the equation to be in this way, first thing that you have to do is to try as much as possible to differentiate them term by term. So you'll be obtaining the expression to be in terms of dy dx, x and then y. Okay, so now you make dy dx the subject. After making dy the subject, then you have your final answer. And then one of the things that you have to notice is that if you have y which stands alone, when you differentiate it, you have dy dx, and then when you have y squared, you have y dy dx. If you have y to the power 3, you have 3y squared dy dx. And then it is also useful to also note that if you have x, y, two different functions multiplying, or they are in this form, you treat them as a product. So you use the product rule to differentiate it, and you have them in this way too, which is a function over another function, which is x over y, or something like this. That one too, you treat it as quotient. So you use the quotient rule to resolve that particular expression. So now we have this question which I cite as an example in my explanation. So we will use that one as a simple example, then we solve it to better our understanding, or to look at what we meant by the whole explanation that we just did. So now we have this function on the board, which is what? X squared plus y squared equal to 5x squared. Now you have to differentiate them term by term. So when you take this, then you differentiate what? You differentiate the x squared, that is the first thing, plus you differentiate the y squared equal to, we have this 5 which is the constant here, that one it won't affect anything. Then into bracket you differentiate the x and y here. All right, we have them in full. So now let's see how we can differentiate these expressions. Okay, now when you differentiate x squared, we have 2x. Okay, plus when you differentiate y, remember in the notification that we dealt with, or we talked about, when you differentiate y to the power 2, you have 2y dy dx, okay, equal to, now we have this expression which seem to look at look like a product. Okay, so we have the constant outside. Now when we are differentiating this, it is y multiplying x, or x multiplying y. So there you treat it as what? A product. So we use the product rule. So how did we learn how to differentiate the product? Now we have these two expressions. So you keep the first one, which is x, then you differentiate y. When you differentiate y, you have y dy dx, plus, in the first place we kept x, right? So here we keep y, then we differentiate x. When you differentiate x, you have what? 1, then you close the bracket. Okay, now the next thing that you're having is 2x plus 2y dy dx equal to 5. will multiply this, so we have 5x dy dx, plus y times 1, we have y, times 5, we have 5y. So having gotten this expression, then the third rule, or the third step that we look at, is to make what? Dy dx the subject. So here we will have to find a way to make dy dx the subject. So now we will move dy dx to one side of the equation, and then those that do not have dy dx, so it's more or less like grouping like terms. Okay, so we have 2y dy dx here, then we look at them, we have dy dx here, so we move that one to this, so minus 5y dy dx. Okay, so now we have equal to, we have 5y here, so 5y, then minus 2x, right? So that's for 1 2 3 4. So we have 1 2 3 4. Now that is it. So here we will factorize dy dx out. So we have dy dx out into bracket, we'll be left with 2y minus 5x equal to 5y minus 2x. Okay, so here we want to make dy dx, so we divide both sides of the equation by 2y minus 5x. So dy dx will be equal to 5y minus 2x all over 2y minus 5x, and this will be the solution for the question on the board. So what did we do? First, you have to differentiate term by term. Okay, so we differentiate x squared, we differentiate y squared, and we differentiate what? 5xy. Also, everybody, or every expression, we divide, we differentiate them. So having differentiated, we will have 2x plus 2y dy dx equal to 5. then we treat this as a product using the product tool, then we differentiate it. Okay, so from there, then this is what you'll be obtaining. So after that, then we group like terms, okay, because we want to make dy dx the subject. Okay, so we group like terms so that we can make the dy dx subject. So we factorize dy dx the subject here, we'll be left with this expression. Then we divide both sides of the equation by 2y minus 5x, and then we will be obtaining this solution, and this will give us the solution for this. Now we have this question on the board, which is x squared minus 3xy plus 5y squared equal to 30. So just like we did with the previous question, what you do is to differentiate them term by term, okay, and then we treat expressions like this as product. Okay, so now when we differentiate x squared, we have 2x minus, now we have this constant, so we bring it out, open the bracket. Now we treat x and y as a product. Okay, so we differentiate x with respect to y, and then we differentiate y with respect to x. So what we do is we will keep x, then we differentiate y, so we have dy dx, plus we keep y, then we differentiate x, we have 1, okay, into bracket, plus we differentiate this. Okay, so we have 10y dy dx equal to, when you differentiate a constant, this is 30, so when we differentiate a constant, we have what? 0. Okay, so now here we will expand this bracket, so we have 2x minus 3x dy dx plus minus 3y, because when we multiply this by that, we have y, by this we have minus 3y. Okay, so now plus 10y dy dx equal to 0. Okay, so now we group like terms because we want to make dy dx the subject. Okay, so grouping like terms, we have minus 3x dy dx plus 10y dy dx equal to, now moving this to this side, we have 3y minus 2x. So now from here we will factorize dy dx out, so we have dy dx into bracket minus 3x plus 10y into bracket close equal to 3y minus 2x. So from here we will divide both sides of the equation by this bracket, which is minus 3x plus 10y. So we will be obtaining our solution to be dy dx to be equal to 3y minus 2x all over minus 3x plus 10y. So over here we can decide to, rearrange it to get dy dx will be equal to 3y minus 2x all over 10y minus 3x. Okay, 10y minus 3x. So I have just rearranged it by bringing the 10 in the in front and then minus 3 at the back. Okay, so this will be the solution for this particular example. At this point, I would like to show you a very simple way of differentiating an implicit function, okay, using the same question that we used in the previous question. Okay, so I will do that, then we will compare this answer with the answer that we obtain when we solve this using the actual way or the actual method of implicit function. All right, so with this one, the simple way is we use it when we are solving, or maybe when you meet this question in an objective test, or when you are doing quiz. Okay, so in quiz, when you are asked just to just give an answer, you use the simple way to do it. But when you use it in the theory, maybe you meet this question in the theory, then you use the simple way. Maybe you may get the answer correct, but you will lose a lot of marks, because mathematics is not marked based on only the answer that you obtain, but rather it is marked on based on the method and the procedures that you follow to arrive at your answer. So beware. The simple way, you just use it when you are dealing in objectives or when you are doing quiz. Okay, so how do we do this? Now dy dx is what you write first, to be equal to, then you write a negative, minus, then you open a bracket, then you partial differentiate with respect to y. Okay, all over, then the same partial differentiation with respect to x. Way to differentiate implicit function is x squared plus y squared equal to 2xy. Over here, the first thing that you have to do is to move this to this side of the equation. So we have x squared minus y squared minus 2xy equal to 0. So from there, then you go ahead and do the differentiation. Okay, so we have dy dx just like we did with the previous question. Okay, now we will be minus then partial differential with respect to y, so we concentrate on the x's. Okay, so now when you differentiate x, you have 2x here, then we forget about this y. Why? Because it doesn't have any x variable over there. Okay, but if we should even concentrate on it, we know that here it is x to the power 0, and x to the power 0 will give you 1, and 1 times y squared will give you what? Just y squared. Okay, but so when you do it, when we are differentiating, the x to the power 0 will come down to multiply this man. All right, so when it comes down to multiply y squared, if it turn everything to 0, that is why in the first question I didn't tackle the y. Okay, I just left it when we are differentiating with respect to the y. Okay, we just leave it out. So now minus this will give us 2y, because the same way that we did when differentiate x, you have 1, and then it will left with what? 2 times this, and then we have what? 2y over. Now we did with the x, so here we deal with the y. So straightforward here, we forget about this x. Okay, so we look at what? Y. So when differentiate this 2y, you have what? Y squared, you have 2y. Okay, minus here the same way we did for here, you will be obtaining what? Minus 2x. Minus 2x, because we are differentiating with respect to x, so y will be out. Okay, so from here we can simplify and have it in this way: dy dx will be equal to minus, here we can factorize 2 out rather. Okay, so when you factorize 2 out here, it will be 2 into bracket x minus y. Okay, over here too we can factorize minus 2 out. When you factorize minus 2 out, it will turn this one to negative. Okay, and it will turn here to positive. So I will have it as x minus y. Okay, so if it is x minus y, this 2x then cancel this, and this one too will cancel that. All right, and then the answer will be equal to what? 1. So when we differentiate this using the implicit function, the answer that you will be retaining will be what? 1. All right, so this will bring us to the end of differentiation of implicit function. If you are new to this page, make sure you subscribe, and then share, like, and leave your comments, and share for the benefit of others. Do have a nice day.